Okay, hey everybody. This is take two. My first one I didn't like. Way too long, so hopefully this is better. Okay, let's just cover real quick for video 3, special right triangles. We have 2 of them we care about, right? 30, 60, 90. Remember, the short leg. This is, let's say it's x. This hypotenuse is going to be, remember, from the short leg to the hypotenuse, we multiply by 2. The hypotenuse is twice what the short leg is on the 30, 60, 90 triangle. So if you know the hypotenuse, you divide by root 2 to get to the short leg. If you know the short leg, you multiply by root 2 to get to the hypotenuse. All right, the other arrow is for from short leg to long leg. If your short leg is again x, we multiply by the square root of 3. So this is x root 3. If you know the long leg, to get back here, you divide by root 3. Okay? All right. So whatever the short leg is, multiply by root 3. If you know the long leg, to get back here, you divide by root 3. And then to get to the hypotenuse, you double it. Okay? It so happens our hypotenuse on a unit circle is going to be 1. So we're going to divide that by 2. The short leg, because this is the hypotenuse will be our radius on the unit circle. Okay? There's our hypotenuse, which is the radius. It'll be 1. So the short leg would be 1/2, because we divide this by 2, or we multiply by 2 and double it. And remember, we multiply the short leg by the square root of 3. Well, 1/2 times the square root of 3 is going to be root 3 over 2. Remember these numbers, you'll see them a lot. Okay? Next one. 45, 45, 90. These legs are congruent. This is an isosceles right triangle. Okay? You take whatever the leg is. Let's say it's x, and you multiply it by root 2. So if you're going from the leg, or from this leg, to the hypotenuse, which is going to again be in the unit circle, if this is 45 degrees right here, this is 45, this is our radius is 1, okay? So here's our radius of 1. So this, if you know this leg, you multiply by root 2. So this would be x root 2. Okay? If you know the hypotenuse, you divide by root 2 to get back here. Okay? Alright, so for our leg times root 2 to hypotenuse, divide by root 2 back to leg. For the unit circle, this is 1. This is our radius, that's 1. So our leg is going to be 1 divided by root 2. Okay? And finally, so this is going to be the same thing, 1 over root 2. But we don't like that. We don't want the radical, the square root symbol, that's a radical in the denominator. So we're going to change that by what? We multiply top and bottom by that root 2. And that gives us up top the square root of 2, and on the bottom 2. That's what root 2 times root 2 gets me 2. That's because root 2 times root 2 is the square root of 4, which is 2. Okay, so that's really what you're going to see here is root 2 over 2, root 2 over 2, okay? If I multiply the top just by root 2, it gives me root 2 times root 2, which is 2 over 2, which is 1. Okay? Just remember these two numbers. You're going to use them a lot. Okay? But remember the rules on the special right triangles. Okay? Leg to hypotenuse times by root 2. Okay? Unit circle time. Remember, we're going to start here This is our initial side. We use the x-axis. An angle in standard position is where the vertex is at the origin. The initial side is the x-axis. And the terminal side, they call it, is where we end up, let's say right here. That's the terminal side. That's an angle in standard position. Angles are said to be coterminal, where, let's say this is 60 degrees. Well, I can go all the way around again, and an angle of 420 degrees. Let's say I go 60 degrees, and I add a whole nother revolution. Well, 60 plus 360 is 420. So a 60-degree angle or a 420-degree angle share the same terminal side. They're said to be coterminal. Also, if I add another 360 degrees, that would be 780. So 60, 420, and 780 are coterminal. 60, let's go another 420, 780. We all end up right here, okay? Now let's talk a little bit about the word radians as we keep deleting it out of our calculator, okay? If this is unit circle, this radius here is 1. So the circumference all the way around, the length of this red circle is 2 times pi times r. Well, guess what? If r is 1, the circumference is 2 pi. Okay? So starting here again, positive is going to be this way when we rotate around making angles. Negative is this way. But if I go 360 degrees, we just said on a unit circle with the radius of 1, that's 2 pi. Okay? So 2 pi is right here. It's 1 revolution, which equals 360 degrees. So if all the way around is 360, or 2 pi, what's half the way around? Well, that's 180 degrees, or just pi. Okay? Well, this is going to be, if 180 is pi, what's half of 180? 90 degrees? So if we go 90 degrees, that's half of 180 or half a pi. That's pi over 2. That's half a pi. 1/2 pi. So 90 degrees are increments of pi halves. Half a pi, half a pi. Here's another half a pi. So this is down here is 3 pi halves. Okay? So radian-wise, 90 degrees is pi halves. Okay? Notice if I make a 30 degree, let's say this is 30 degrees. That's pi 6. Why would that be? Well, 30 degrees is what? 1/6. 180. So 180 divided by 30 equals 6. So really 30 degrees is 1/6. There's 6 of those. 1/6 of 180. So if 180 is pi, 30 degrees is 1/6 of pi, or pi 6. That's radians. Okay? We'll get into a little more of the conversions, but we're going to start using radians more often now. Okay? That's about it. I think that's going to give you a lot of help for doing the next assignment. Remember, different angles, what we learned is different angles can be, or different, here we go, stumbling guys. Hey, different representations can be the same angle, okay? So that would be 1 pi halves, 2 pi halves, 3 pi halves. So 3 pi halves can also be what? 4 pi halves, 5 pi halves, 6 pi halves, 7 pi halves. So 3 pi halves equals 7 pi halves. They're the same spot, okay? We'll get into a little more. I think that's going to be enough for us to get going on the assignment. Oh, let's forget, the raffle. for the big Chick-fil-A. I'll give this out Tuesday. I'll dig down deep because I know Secretary went for it. I'm mixing them all up. Let's see what I pulled out. Who's the winner? Ooh. It's Maritza Herrera. Psych. No, it's not. It's Humberto Duran. Humberto, the big winner of the Chick-fil-A gift certificate. Sorry, Maritza, I had to play with you. All right, that's it. You guys have a good one. I'll see you tomorrow, okay?